You can technically cram billing, technical support, and refunds into one giant system prompt. It works in a demo and falls apart in production. The model gets confused about which policy applies. Your prompt becomes thousands of unmaintainable tokens, and you can't reason about behavior per domain. In this video, we build a multi-agent customer support system on Azure AI Agent Service in Python, where a triage agent routes each conversation to a specialist and hands control off cleanly. I'll cover the mental model, how handoffs actually work under the hood, the Python wiring, and the production gotchas that bite people. Let's get into it. First, the primitives. In Azure AI Agent Service, an agent is a server-side resource. It bundles a model deployment, instructions, and a set of tools. A thread is a persistent conversation that stores messages for you, so you're not resending history every call. When you want a response, you create a run, which executes the agent against the thread. The service handles tool call orchestration, state, and the model loop. The key insight for multi-agent. Each specialist is just another agent resource with its own narrow instructions and its own tools. You are not managing one model with branching logic. You are composing several focused agents and deciding who owns the thread at any moment. Here's the mechanism people miss. There's no magic teleport between agents. A handoff is just a tool call. You give your triage agent a function tool like route and sarbilling. The model decides to call it. Your code sees that tool call in the run, and you respond by creating a run for the billing agent on the same thread. Because the thread is shared, the specialist sees the full conversation context with no copying. The connected agent pattern formalizes this. You register specialist agents as tools on the orchestrator, and the service surfaces their invocation as a tool call you resolve. The takeaway: a handoff equals detect tool call, switch which agent runs the next turn. Here's the shape in code using the Azure AI Projects client. You create each specialist agent, then create the triage agent with connected agent tools pointing at them. The SDK exposes specialists as callable tools, so the orchestrator can delegate. You create one thread, post the user message, and start a run on the triage agent. When the run completes, the connected agent tool has already executed the specialist for you and merged its reply into the thread. Authenticate with default Azure credential and managed identity, never a hard-coded key. API shapes change, so check the current Azure docs for exact class and method names before you ship. Zooming out to the architecture. Your client app talks to a PI management, which fronts a thin orchestration layer in container apps. That layer owns the thread and calls a AI agent service, where the triage and specialist agents live. Specialists invoke real tools, an Azure AI search index for knowledge-based lookups, and a functions app that wraps your order and billing systems. Secrets and connections live in Key Vault. This keeps the agents stateless about infrastructure while your business logic stays in tools you control and can test independently. Now the things that bite you. First, ping pong. Two agents can hand back and forth forever, so cap turns and add a fallback to human path. Second, context bleed. Because the thread is shared, a specialist sees everything, including instructions meant for triage. Keep instructions scoped and don't leak routing logic into specialist prompts. Third, cost and latency. Every handoff is extra model calls, and connected agent patterns can fan out fast. Watch token usage per thread. Fourth, thread lifecycle. Threads persist server-side and accumulate, so you own cleanup and retention for compliance. Fifth, tool failures. A specialist's tool call can throw, and you must decide whether to retry, apologize, or escalate rather than letting the run hang. One design decision worth calling out: do you let the triage model decide routing, or do you hard-code it? Model-driven routing via connected agent tools is flexible and handles fuzzy requests, but it's non-deterministic and harder to test. Deterministic routing. where your orchestrator inspects intent and picks the agent in code, is predictable and cheaper but brittle to phrasing. A pragmatic rule of thumb: use model routing for the first-line triage decision, then deterministic guards for high-stakes actions like refunds, so a model can't accidentally trigger a payout without an explicit confirmation step. To recap, in Azure AI Agent Service, agents bundle a model and tools, threads hold state, and a handoff is nothing more than a tool call that switches which agent runs the next turn on a shared thread. Compose narrow specialists instead of one mega prompt, ground them with tools you control, cap your turns, and guard high-stakes actions deterministically. Your concrete next step: build the smallest possible version first, a triage agent plus one specialist on a single thread, and trace exactly when the handoff tool fires before adding more agents. Service APIs and pricing shift often, so verify the current Azure docs as you build. If this helped, subscribe for more architecture deep dives. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.